Hi there, in the last video I explained one of the cases for partial fractions and I also showed its application to an integration problem. So if you haven't watched that video, I would encourage you to watch that previous video that I did. So in the previous video I explained what you do when you have linear factors in your denominator and how you would write it in the form of two fractions or a summation of two fractions. And I also explained the methods to working out a and b, the constants. Okay, so if I quickly take that example, so here we had two linear factors in our denominator, so we write this as a divided by one of the linear factors plus b divided by the remaining linear factor, and I explain the method to working out a and b, the constants. So we also integrated the fraction here. So in particular we integrated these two fractions separately. Okay, so if you haven't watched that video, again, be sure to watch that video. So in this video I'm going to explain another case for partial fractions. So in this case, I'm going to call this case number 2. So case number 2 is whereby you have a quadratic factor appearing in the denominator. So if you have a quadratic factor appearing in your denominator, so this is what case number 2 is about. So let me underline this. So let me take an example explaining this case. So if we have x squared minus 3 over x minus 1, okay, into x squared plus 1. So once again we have a proper fraction. So proper means, remember, the highest power of x in the numerator is 2, and when you expand the denominator, the highest power of x in the denominator is 3. So we have a proper fraction, so that means we can apply partial fractions. But in this particular case I have a quadratic factor, so let me highlight this. X squared plus 1 is our quadratic factor, and the remaining term is a linear. Okay, so when you rewrite this, you would rewrite this as a divided by the linear factor, so the linear factor is x minus 1, okay, plus bx plus c divided by your quadratic factor. So your quadratic factor is x squared plus 1 in this case. So when you rewrite this, in other words, the numerator of your quadratic factor will be bx plus c. So it will be of the form bx plus c, and that is all one term. Okay, so it's a divided by your linear that you have plus bx plus c divided by your quadratic. Okay, so once again a, b and c are constants that we need to determine. So where a, b and c are constants to be found. So I'm going to use exactly the same method that I've used in the previous video to work out the constants, which in this case are a, b and c. Okay, so let me explain the method to working out the constants. Step number 1, as I explained in the previous video, look at this term that you have as a whole in the denominator. So the term as a whole in your denominator is x minus 1 into x squared plus 1. So you need to multiply this entire equation by that term that I've highlighted in green. Okay, so by multiplying star by x minus 1 into x squared plus 1. So if we do the multiplication, this is what we're going to have. So we're going to have x squared minus 3 on the left hand side, and that is equal to a into x squared plus 1 plus bx plus c, okay, into x minus 1. Okay, so I'm going to call that equation number 1. So this is what I did in case number 1 in the previous video, exactly that step. So we multiplied the entire equation by the term appearing in your denominator. Okay, so no tricks here, exactly the same step to working out the constants only. Over here in step number 2, to work out one of the constants, you need to choose a value of x to eliminate 2 constants in this case in order to work out the remaining constant. Okay, so if I look at this equation, if I look at this term in particular, if I take x as 1, so if I choose x to be 1, I can eliminate 2 constants b and c to work out the constant a. Okay, so I'm going to do that very step. So if I put x equals 1, okay, into equation number 1, I can eliminate b and c, so this entire term, to work out a. So by doing that, we'll have x, which is 1 squared minus 3 on the left, okay, that is equal to a into x, which is 1 squared plus 1, plus a b into x, which is 1, plus c into x, which is 1 minus 1. Okay, we know that this term is going to be 0, but I just want to stress that we chose x as 1 because this term 1 minus 1 is 0, so that would eliminate this term here. Okay, 1 squared minus 3, that is minus 2 on the left hand side, that is equal to 1 squared plus 1, that is 2, 2 times a, 2a, okay, and a will be, when you rearrange, minus 1. So that's going to be the constant a straight away. That takes us to step number 3. So in step number 3, let me put that a value of minus 1 back into equation 1. So if I put a is equal to minus 1 into equation number 1, we're going to have x squared minus 3, that is equal to a, which is minus 1, into x squared plus 1, plus a bx plus c into x minus 1. Okay, now in the next step, so we have constants b and c to determine. So to work out one of the constants, so if I choose x equals 0, I could eliminate my b term to work out c straight away. Okay, so if I take x as 0, let's eliminate that b term to work out c. So we're going to have x, which is 0 squared minus 3 on the left hand side, that's equal to minus into x, which is 0 squared plus 1 here, plus b into x, which is 0, plus a c into x, which is 0 minus the 1. Okay, 0 squared minus 3 is minus 3 when we simplify. That is equal to 0 squared plus 1 is 1. Don't forget that minus, it's a minus 1. Okay, and c from here times minus 1 is minus c. So when you rearrange, c is going to be 2. Okay, so that should be the value of c. Now let me put c is equal to 2 into this equation here. Let's call it equation 2. Okay, so I think a fresh piece of paper is in order. So in step number 5, let me put c is equal to 2 into equation number 2. So here is equation number 2 that I've named earlier. So if I put c is equal to 2 here, this is what we're going to have. So we're going to have x squared minus 3, that is equal to minus into x squared plus 1, okay, plus bx plus c, which is 2, into x minus 1, okay. So we only have b to calculate, and to calculate the final constant, so we can use the same idea as I mentioned in the previous video. So to work out the final constant, you can choose any value of x except the values of x that you've used in your method. Okay, so let me repeat. You can use any value of x now except the values that you used earlier. So we've used, let's remember the values that we've used. We've used x equals 1 and we've used x equals 0. So don't use those values, you can take any other value of x. Purely because if you take x equals 1, the value that you've used earlier, okay, 1 minus 1 is 0, that would eliminate the b term. And if you use x equals 0, as we've used earlier, b times 0 is 0, that's pointless, okay? So you can use any value of x except the ones that you've used. So I'm going to use x equals 2, say. So I'm going to put x equals 2 into, and let me call this equation 3. And by doing this, this is what we're going to have. We're going to have x, which is 2, so 2 squared minus 3 on the left hand side. And that is equal to minus into x, which is 2 squared plus 1 here, plus b times x, which is 2, is 2b plus 2 into x, which is 2 minus 1. Okay? So if we simplify that carefully, 2 squared minus 3 is 1 on the left, that is equal to 2 squared plus 1 is 5, times minus is a minus 5 here, okay, plus 2b plus 2 times 1 from here is 2b plus 2, okay. So when you rearrange carefully, you might find that the b value is 2. So that's the value of the constant b. So we found the values of our constants. A is minus 1, okay? C is 2, and B is 2. So let's put those values into the equation that we had at the start, okay? So A is minus 1, C is 2, B is 2. So when we plug these values into the very first equation, we're going to have x squared minus 3 over x minus 1 into x squared plus 1. That is the same as A is minus 1, so minus 1 in over x minus 1, plus B, so B is 2, so it's a 2x, remember, so quickly going back, it's a bx plus c, so it's going to be a 2x, plus c, which is 2, divided by x squared plus 1, okay? Now I'm going to go through the third case. So I'm going to call this case number 3. This is the case whereby you have repeated factors in your denominator. So let me take a red pen and a ruler quickly and underline this. So let's take this example of such a case. So if we have 1 plus 2x minus x squared divided by 1 plus x to the power 2 into 1 plus 2x. Okay, so as you can see over here, I have a factor of 1 plus x repeated twice. So here is my repeated factor. so as 1 plus x is repeated twice, and here is my linear factor. So if you have such a case, you could rewrite this as a divided by your linear factor, so the linear factor being 1 plus 2x, plus b divided by one of the repeated factors, so one of them is 1 plus x, okay, plus c divided by 1 plus x to the power 2, okay. So supposing if this power was a 3, then you would write this as a divided by your linear plus b divided by one of them plus c divided by 1 plus x squared plus d divided by 1 plus x cubed. Okay, so you continue until you reach the power term that you have here. Okay, so this is the arrangement when you have the repeated factor case in the denominator, and the principle for working out a, b and c, the unknown constants, is exactly the same. So what are a, b and c? So where a, b and c are constants to be found. Okay, so as I've done in the previous videos, let's call this equation star, and in step number 1, look at the entire term in the denominator of this fraction. So I'll circulate that term in green, and you need to multiply this equation, which I named star, by that term highlighted in green. So by multiplying star by 1 plus x squared into 1 plus 2x. Okay, so let's multiply this entire equation by that term. So we're going to have 1 plus 2x minus x squared on the left, and that is equal to, now be careful when you multiply, you're going to have a into, okay, 1 plus x squared plus b into 1 plus x into 1 plus 2x plus c into 1 plus 2x. So be careful when you multiply by that term, okay? So that takes us to the next step, step number 2, okay? So in step number 2, we need to work out one of the constants. So remember the idea as I explained in the previous videos. We need to choose a value of x to get rid of two constants to work out the constant that you want to calculate. Okay, so in this case, if I want to calculate, say, a, so if I want to work out a, okay, looking at my a term, I have a 1 plus x here, so I also have a 1 plus x here in my b term, but for my b term, I've got a 1 plus 2x. On my c term, in my c term also, I have a 1 plus 2x. So if I take x as minus half, so if I choose x to be minus half, I can get rid of b and c in order to work out a. Okay, if you took x as minus 1, you're going to get rid of b as well as a to work out c. Okay, so that is entirely your choice, but I'm going to take x as minus half to get rid of b and c in order to work out a. So if I put x is equal to minus half, and let me call that equation number 1, so into equation number 1, let's see what we're going to have. So as a result, we're going to have 1 plus 2 into x is minus half minus x, which is minus half squared, that is equal to a into 1, x is minus half, so it's a 1 minus half squared, plus a b into 1, and x is minus half, so 1 minus half, multiplied by 1 plus 2 into x is minus half, plus the c, 1 plus 2 into x, that's minus half. Okay? So the reason for us choosing minus half is this term is going to be 0, okay? But also this term here, that's going to be 0 as well, okay? So as a consequence, b and c will be eliminated so that we can work out a, okay? So on the left hand side, these twos can cancel. So you're going to have 1 minus 1, which is 0, and minus into minus half squared will give us minus a quarter on the left. That is equal to 1 minus half is half, half squared is a quarter, times a is a quarter a. So straight away, a is going to be minus 1. Okay? So that's the value of the constant a. Let me put a is equal to minus 1 into equation 1. So in step number 3, the next step, let's put a as minus 1 into equation number 1. So by doing this, we're going to have, so here's equation 1 that I've named, 1 plus 2x minus x squared, that's equal to a is minus 1, so minus into 1 plus x squared, plus a b into 1 plus x into 1 plus 2 of x, plus a c into 1 plus 2 of x. Okay? Now, from here on, we've got constants b and c to determine. Okay? So let's choose a value of x to work out one of them. Okay? So in this case, if I take x as minus 1, so if I choose x as minus 1, I can get rid of the b term in order to work out c. Okay, so let's do that. So let me put x as minus 1 to get rid of b to help us work out c. Okay, so in the next step, step number 4, let's put x as minus 1 into equation number 2. Okay, so in this case, when you put x as minus 1, we're going to have 1 plus 2 into x is minus 1 minus the minus 1 squared, that's equal to a into 1 plus x is minus 1 squared plus b into 1 plus x is minus 1 into 1 plus 2 into x, which is minus 1, plus c into 1 plus 2 into x is minus 1. Okay? So when we simplify this, so the reason why we chose x as minus 1 is because the 1 minus 1 here is 0, and that would cancel that b term. Okay? And we know the a term already, a is minus 1, so let me replace that by minus 1. Okay? So in this case, when you simplify and calculate c, you might find that the value of c is 2. Okay? So let's calculate the remaining term b. So let me put c is equal to 2. So let's call this step number 5 into the previous equation, equation number 2. Okay? So let's do that. So let's put c is equal to 2 into equation number 2. So when we do this, this is what we're going to have. We're going to have 1 plus 2x minus x squared. So 1 plus 2x minus x squared, that's equal to minus into 1 plus x squared, okay, plus the b term, so b into 1 plus x into 1 plus 2x, so plus b into 1 plus x, 1 plus 2 of x, plus c. Now c we worked out, c is 2, so 2 into 1 plus 2 of x. So plus 2 into 1 plus 2 of x. Okay, so that takes us to the next step. So to work out the final constant, so remember, for the final constant, as I've said in the previous videos, you can choose any value of x except the ones that you've used. Okay, so the ones that you used are -1. So don't try -1, because if you put x is -1, that's going to eliminate the b term, as 1 minus 1 is 0. So that is pointless. And we also use, if you remember, x as -half. So even if you put -half here, 1 plus 2 into -half is 0. That would again eliminate that b term. So choose any value of x except the ones that you've used. So I'm going to take x as 0. Okay? So if I put x as 0, this is what we're going to have. We're going to have 1 plus 2 into x is 0 minus x, which is 0 squared. That's equal to minus into 1 plus x, which is 0 squared, plus b into 1 plus x, which is 0, into 1 plus 2 into x, which is 0, okay, plus 2 into, over here, 1 plus 2 into x, which is 0. Okay, so once you simplify that, you might find that the b constant has a value of 0. So we found the values of a, b and c. So a is -1, b in this case is 0, c is 2. So if I replace those values in our initial equation here, so we're going to have 1 plus 2 of x minus x squared divided by 1 plus x squared into 1 plus 2 of x. That's the same as a is -1, so -1 over 1 plus 2 of x, plus b. Now b is 0, remember, so that would eliminate that term. And our c value is 2, so 2 over 1 plus x squared. So plus 2 over 1 plus x squared. Okay? So that explains case number 2, how you would deal with repeated factors in your denominator. So here's the arrangement, and you've seen this method in the previous videos to working out the constants. Now if I continue further, if we had a question whereby we need to integrate this term, 1 plus 2x minus x squared over 1 plus x squared into 1 plus 2x with respect to x. So instead of integrating this large horrible fraction, we can integrate these two fractions separately. So what I'm trying to say is we can integrate -1 over 1 plus 2 of x with respect to x, plus, and we can integrate this term 2 over 1 plus x squared with respect to x also. Okay, so let's continue forward and integrate those two terms. So I'm going to call this first integral star and this second integral double star, and we're going to integrate those two as side calculations. So over to the reverse, let's do a side calculation of star. Okay, so let's look at this integral here. So -1 over 1 plus 2x. So let's integrate -1 over 1 plus 2 of x. So since it's a fraction, let's try f primed over f. So let's see whether f primed over f works. So f of x is the term in your denominator, which is 1 plus 2 of x. Okay? And f primed, when we differentiate, we're going to have 2. Okay? So 2 is related to the numerator, so f primed over f does work, okay? But let's continue the method. So we need to rewrite this integral. So let's rewrite this integral. So the denominator term, keep it as it is, 1 plus 2 of x. And f primed x is 2, so copy out the f primed x over here. So red with red, okay? Now these two integrals don't match, so to make them match, continue the process. So the number, so whatever number you have in your numerator, copy it down here outside your integral. So green with green, so 2 with 2. And to get that -1, the number here, so the number here, dotted black, copy down here. So dotted black, so the numbers here should match when you do the rewriting process, okay? Then check this integral, check whether this integral is the same as the one that you had. So -half times 2 over 1 plus 2x is equal to -1 over 1 plus 2 of x. So these two integrals match. So as my integral here is of the form f primed over f, the answer to this integral is -1 over 2 ln modulus of f of x, which is 1 plus 2 of x, okay, plus c. Okay, so remember the result that I explained in one of the videos, so I'll provide that link to the video in the description below. But remember the results. If you're integrating f primed over f of x with respect to x, the result is ln modulus of f of x add c. So if you're unfamiliar with this result, I'll provide a link to the video that I created whereby I explained the result and I did some related examples in the description below. Okay, so be sure to watch that video. So that is a solution to star. Let's look at double star. So double star is this integral that we have here. So we need to integrate 2 over 1 plus x squared with respect to x. Okay. Now we can't use this result over here. However, we could rewrite this as 2 into 1 plus x to the -2. And remember one of the results that we've seen in a previous video, so if you're integrating a term of the form ax plus b to the power n, the result was ax plus b to the power n plus 1 over n plus 1 divided by the derivative of ax plus b at c. So we're going to use that very result, okay? If you're unfamiliar with that result, I created a video on that result and how it's used, and I provide a link to that video in the description below, so be sure to watch that video. So back to the paper and pen. So let's integrate this term. So I'll have 2, 1 plus x. So if I add 1 to the power, -2 plus 1 is -1. Divide by the -1. Divide by the derivative of 1 plus x. So if I differentiate 1 plus x, we have 1. Plus c, just for completeness. So we could rewrite that as -2 over 1 plus x plus c. Okay, so here are the solutions to star as well as double star. So here are the solutions to these two integrals on the right hand side. So let's continue. So a fresh piece of paper. So just to conclude, so the answer of the integral of 1 plus 2 of x minus x squared over 1 plus x squared into 1 plus 2 of x with respect to x is going to be. So let's remind ourselves, when I integrated star here, the solution was minus half ln modulus of 1 plus 2 of x. Okay, so let's copy that down. So minus half ln modulus 1 plus 2 of x. And the answer of double star, so when I integrated double star here, we had this as the result, minus 2 over 1 plus x. So let's include that, minus 2 over 1 plus x, add c. Okay, so that completes that example finally, and that also ends this video. So I hope you enjoyed this video. I hope you found it useful. If you did enjoy the video, a like is very much appreciated. Do related practice questions, and I hope to see you again. Thank you.